Right now, while your engine feels perfectly normal, there may be a dirty sensor no bigger than your finger quietly stealing horsepower, increasing your fuel bill, and shortening your engine's life without triggering a single warning light on your dashboard. And here's what makes it worse. Most drivers, especially those who've been driving for 20, 30, even 50 years, have never once touched these sensors. They change the oil, they replace the spark plugs, they even swap the air filter every year. But these sensors never cleaned, not once. And by the time the check engine light finally comes on, the damage is already done. This video is for gasoline engines, petrol vehicles. If you drive diesel, some of these apply, but the sensors, their location, and the cleaning products differ enough that they deserve their own video. Don't skip this if you drive gasoline, because what I'm about to show you is the difference between a car that runs like it did on day one and a car that slowly, silently becomes a money pit. Let's start from the bottom and work up to the one sensor that the comment sections of every video on this topic agree is the most overlooked of all. The MAF sensor, mass airflow sensor. Location: in the intake tube between your air filter and throttle body. It usually has a 2 or 4 wire connector and a small housing you can see when you open the hood. This sensor measures every gram of air entering your engine using a platinum wire thinner than a human hair. When microscopic dust, oil vapor, or residue from performance air filters coats that wire, your engine's computer starts receiving wrong data. The result? Unexplained power loss, rough idle, increased fuel consumption, and fault codes that make mechanics replace parts that don't need replacing. If you ignore this sensor long enough, your engine runs rich or lean without knowing it. Over months and years, that incorrect fuel mixture accelerates wear on cylinder walls, oxygen sensors, and catalytic converters, all of which cost hundreds to thousands of dollars to replace. Cleaning product: MAF cleaner only. Never throttle body cleaner, never carb cleaner, never compressed air. Those will destroy the sensing wire instantly and permanently. A can of dedicated MAF cleaner costs about $8 and takes 5 minutes. Spray, let dry, reinstall. The MAF sensor, manifold absolute pressure sensor. Location: usually mounted directly on the intake manifold or connected to it via a short vacuum hose. Look for a small rectangular sensor with a vacuum port and a wiring connector. The MAF sensor measures pressure inside the intake manifold to calculate how hard the engine is working. When the vacuum hose connecting it cracks, and it will crack with age, the sensor reports a completely wrong engine load. Your computer injects excess fuel. You'll notice heavy fuel consumption, black smoke from the exhaust, and a car that feels sluggish. No matter how hard you press the accelerator, left unchecked, running consistently, rich burns out your oxygen sensors and clogs your catalytic converter. Replacing either of those costs $200 to $800. Inspecting a vacuum hose costs nothing. Cleaning product: electrical contact cleaner. On the sensor port and connector, inspect and replace the vacuum hose if it shows any cracking or stiffness. The O2 sensor, oxygen sensor. Location: in the exhaust pipe, before and after the catalytic converter. You will see it threaded into the exhaust manifold or pipe with a wiring connector running back into the engine bay. The oxygen sensor monitors combustion efficiency thousands of times per minute and tells the computer to adjust the air-fuel ratio in real time. When it gets contaminated, most commonly by burning oil due to worn piston rings, or silicone from cheap gaskets and sealants, the sensor slows down, loses accuracy, and stops doing its job. The consequence: you will feel immediately worse fuel economy and sluggish performance. The consequence you will not feel until it is too late: a failed emissions test, a destroyed catalytic converter, and a repair bill that could have been avoided entirely. Important note: for owners of vehicles made after 2005, many modern cars use wideband oxygen sensors, not the traditional narrowband type. They operate differently, and diagnosing them requires a scan tool, not just a multimeter. If your car is newer and you are seeing O2 sensor codes, do not assume cleaning will fix it. Have it scanned first. Cleaning product: oxygen sensors generally need replacement when contaminated, not cleaning. The value here is prevention. Fix oil burning early and never use silicone sealants that are not specifically labeled sensor safe. The TPS, Throttle Position Sensor. Location: mounted directly on the throttle body shaft, on the side opposite the throttle cable or actuator. It moves with the throttle plate. The TPS tells the computer exactly how much power you are requesting with your foot. When it develops problems, you feel hesitation and jerking at specific pedal positions, usually cruising speed or light acceleration. The exact moments you use most often. Here's something most videos don't tell you. If your car was made before roughly 2005, your TPS is likely a traditional potentiometer, with a physical wiper that wears out over time. Dead spots develop and the signal drops. If your car is newer, it likely uses a non-contact Hall effect sensor that does not wear the same way, but can still fail from connector corrosion or heat damage. Cleaning the connector with electrical contact cleaner solves a surprising number of TPS-related complaints. Before you spend $60 to $120 on a new sensor, clean the connector first. The Crankshaft Position Sensor. Location: near the bottom of the engine block, close to the crankshaft pulley or flywheel. It's often partially hidden and surrounded by heat and oil. Without this sensor, your engine is blind. It can't time the spark. It can't time the fuel injection. When it accumulates metal debris, burnt oil, or grime on its tip, you get intermittent misfires, random stalling when the engine is hot, or a car that cranks but won't start on a warm restart. 1. Critical warning: intermittent crankshaft sensor failure can cause your engine to shut off at highway speed without warning. If you're experiencing random stalling, especially when the engine is hot, don't dismiss this. Clean the sensor tip with electrical contact cleaner and a lint-free cloth. If the problem continues, replace the sensor. It's not expensive, and ignoring it is genuinely dangerous. The ECT Sensor, Engine Coolant Temperature Sensor. Location: threaded into the cylinder head, the thermostat housing, or a major coolant hose. It has a single or two-wire connector and sits in direct contact with your coolant. This sensor is the engine's thermometer. Every fueling decision your computer makes during a cold start, warm-up, or hot running condition depends on this single reading. When it corrodes or loses calibration, the computer can believe the engine is permanently cold and keep applying a cold start rich fuel mixture all the time, every drive, forever. The consequences are severe and cumulative. Fuel consumption spikes. Your cooling fans may not activate at the right time, pushing the engine toward real overheating. Hot restarts become difficult or impossible. And in the worst case, an engine that overheats silently because the computer never commanded the fans to turn on. Always work on this sensor with the engine completely cold. The cooling system is pressurized when warm and can cause serious burns. Clean the connector terminals with electrical contact cleaner. Green oxidation or white buildup on the pins is a direct indicator of signal corruption. The IAT Sensor, Intake Air Temperature Sensor. Location: often integrated into the MAF sensor housing. In vehicles without a MF, it's a standalone unit mounted in the intake manifold near the air filter housing or in the throttle body. This sensor tells the computer whether incoming air is cold and dense, requiring more fuel, or hot and thin, requiring less. When contaminated with dust, oil vapor, or intake residue, its readings drift. The engine feels inconsistent, runs fine one day, sluggish the next, with no explanation you can find. Use only electronic contact cleaner or dedicated sensor cleaner. The thermistor element at the tip is extremely delicate. No compressed air, no sandpaper, no brushes with stiff bristles. Light spray, gentle wipe if needed, let dry completely before reinstalling. The IAC valve, idle air control valve. And here it is, the component that comment sections on every video about this topic keep demanding be included. The one sensor most often blamed for poor idle, unexplained stalling, and rough cold starts. The one that almost nobody cleans. Location: on or near the throttle body. It's a small valve, sometimes cylindrical, sometimes rectangular, with a wiring connector. It controls how much air bypasses the throttle plate at idle. The IAC valve is what keeps your engine running smoothly when you're sitting at a red light, when the air conditioning kicks on, when you come to a stop after highway driving. It compensates for all the loads that would otherwise drop your idle RPM too low when it gets dirty, and it will, because it's sitting in the intake path where oil vapor, carbon deposits, and grime accumulate constantly. It gets stuck. A stuck open IAC causes high idle that won't come down. A stuck closed IAC causes low idle, rough running, and stalling, often right when you stop at a light or during the first few minutes of a cold start. If your car stalls at idle, if your RPM hunts up and down at a stoplight, if the engine runs rough for the first minute after a cold start and then smooths out, this valve is the first thing you should clean. Not the spark plugs, not the fuel injectors. This valve, cleaning. Remove it from the throttle body. It's usually 2 or 3 bolts. Spray the inside thoroughly with throttle body cleaner, not MAF cleaner. Use a soft brush or clean cloth on the carbon deposits around the port. Let it dry completely before reinstalling. This procedure alone has fixed idle problems that shops were quoting $400 to $600 to diagnose and repair. The connector underneath everything. Before you replace any sensor, clean its connector first. Oxidized, corroded, or loose terminals cause intermittent fault codes, warning lights that come and go, and symptoms that move around and confuse everyone, including professional mechanics. Use electrical contact cleaner on both sides of every connector. Let it dry. A thin layer of dielectric grease around the connector seal, never directly on the pins, prevents future moisture intrusion. This single step eliminates more phantom problems than any part replacement. Here's the bottom line. Every sensor on this list fails gradually, not all at once, not dramatically, slowly, silently, one reading at a time, until the day your car runs badly enough to notice, and by then, you've already been paying the price in fuel, in performance, and in premature wear, on parts that cost far more than $10 can of cleaner. You don't need to be a mechanic. You need about an hour, the right cleaner for each sensor, and the awareness that these components exist and need occasional attention. The car that gets maintained at this level doesn't just run better. It lasts longer, it costs less, and it never becomes the car you're embarrassed to take to a shop because you don't know what's wrong with it. clean these sensors, start with the IAC valve. Your engine has been waiting for this.